which is called MQTT. It's a functionality that we are supporting through intelligent control, and I'm presenting today here with my colleague Anton Thiele. So as you see on the next slide, the webinar is being recorded, so no worries afterwards. If you have missed it, you can still review it. We will share it through email afterwards so that you have the direct link. If you have any questions, please keep them till the end of the presentation, and then we go through them and we will answer them as good as possible. And if you look at your user interface, you can see at the right bottom corner, you can post your question. Please make sure that you send them to all the presenters in the panel list. So yeah, myself, Maarten Wings, marketing manager for EMEA, and I'm here today with Anton Thiele, who is application engineer for public address and voice alarm. So what are the objectives of today? We would like to give you a brief understanding of what actually an MQTT protocol is and how you can use this in your projects. What devices can be supported through MQTT, and also how we bring that to market in our portfolio, namely through the PXI-Core Edge controller. So what will briefly be the topics that we run through? So first, what is again the PXI-Core Edge controller? What is Intelligent Control 2.1? And then we talk about MQTT protocol itself and how to set up a basic MQTT integration with some examples so that everything becomes a little bit more vivid. Good, let's start with a small recap. PXI-Core Edge controller, we introduced this device before already. It is commercially available, and this is actually what it looks like. So it is a small, compact industrial PC device, which is 19-inch rack mounted. You can just mount it on a DIN rail. Very compact device. It is running a Linux core and has multi-core CPU performance, as you see. Also, we have high level of security, cybersecurity in place on this device, and we have it ready for multiple extensions. Yeah, as I mentioned, it is DIN rail mountable. So if you have a PRAESENSA system already in the racks installed, this is a device which you typically can install close to that to the PRAESENSA system. But since it is IP based, you can basically install it anywhere in your project. Okay. So intelligent control, what is it? As you see here on the next slide, there is actually multiple levels of integration. So one level is very, very basic, which is not very intelligent one and not based on communication protocols. It's just the closure of contacts between systems. This, however, is something which sometimes is still required because it's an EN54 certified way of communication, but there is not really smartness or logic behind. So every connection you make, you need to wire an IO, which especially for many integrations will become very complex and also time consuming and labor consuming to realize. So then we have on the right side, maybe I go there, you see building integration system. So this is the full-fledged integration between a software management on top and systems that are controlled and supervised below. So if you have the building integration system, this adds logic to the rule engine and you can basically configure everything. It's a very a high level integration capability with a lot of flexibility, but also with a software layer on top, which allows an operator to operate the system. Yeah. And then we have the red box, and that is actually something in between. It's not wiring contacts, but it is also not a full-fledged management software with a user interface. It's actually something in between. It's actually, let's call it logic wiring of contacts. So we have an input device and we have an output action, and we can make logic over software with this. We make basically logical rules. But there is no user interface to operate it. It's an embedded system, and once the logic is programmed, it runs. I think you can very much compare it to maybe a PLC. if you look at this in the industrial field. Okay, let's go to the next slide. So what does it do? What can be controlled with this intelligent control application that is running on the PXI-Core? So the PXI-Core is the hardware and intelligent control is the software. So if we have intelligent control running, one of the things we, for instance, can do, we can build an integration between PRAESENSA, Presidio, intrusion alarm panels from G-series and on-VIF cameras. So we have various devices and systems, and we can make logical rules instead of wiring contacts, which makes it much more flexible. Yeah. Okay. So we have a web interface which you can log on to the PXI-Core, which allows you to start configuring the intelligent control software. This is not a web interface that is used for operators to operate it. It's a web interface that is used for configuring logical rules. So there is a big difference. It's not like with BIS that you have an operation interface. Yeah. Okay. Yeah, we have high level of security in place on this device. And then the next bullet, ready for extensions. Okay, good. Now let's move further. So here is an example of a use case that we could configure. Let's say somebody opens an emergency door. So what we could do, we could take an input from a system, let's say a magnetic contact from a intruder alarm panel. And this input we can use in a logical rule in the intelligent control that is running on the PXI-Core, where we tell the system that if the door is opened, an announcement needs to be made through the PRAESENSA system in a specific zone. So this is a logical rule that we could configure through the web interface in intelligent control on the PXI-Core. Okay, here is another one. A message is sounded when the fire door is blocked by a box. We have another sensor here. A camera is monitoring the door and it is using the video analytics. If an object is placed in front of the door, then this camera shall give a video analytics event to the PXI-Core. And then we can make again a logical rule that the PXI-Core needs to process something. Like in this case, again, we have a PRAESENSA zone with a specific speaker that is close to the door, where we make an announcement that it's not allowed to put a box in front of the fire door because you are blocking the emergency exit. Yeah. So that's the second use case example. Third one, somebody enters a prohibited area. So let's say there is an area in a building or near a railway platform or whatever, places where people are not supposed to be. Also there we can use a sensor, either in an intrusion alarm because a specific door is opened, or a camera because a certain area is entered. And then this sensor will create an event. This event we can use as an input for a logic rule. And here again, we can make an output or an action towards the PRAESENSA system that it needs to play a specific message. Yeah. So now door refrigerator in the supermarket, let's say, yeah, there is a lot of energy consumed near the refrigerator. So now they close doors to keep all the cool inside. Somebody leaves the door open. Also here, this can be a trigger towards the PXI-Core, which we can use for logical programming in intelligent control to make an announcement in a zone in the PRAESENSA system. Good. Here, a fifth use case. Let's say somebody see who opened the door when a specific door is open. So a specific person opens the door. Also here, magnetic contact is used as an input, and a logical rule could, for instance, in this case, pre-position a camera. So it's now not a use case with the PRAESENSA system, but it's another device which can also execute action. In this case, a camera can be moved into a specific position, which we can also program through a logical rule. Yeah. Then watch a zone or area when you make a specific call. So if you make a live announcement on PRAESENSA, you often are not in the same area as where you are addressing the call. So if the live call is being made and it's being played, then intelligent control could put the camera in a specific pre-position so that you can actually monitor if people are actually responding to the call that you are making. So also here again, it's always an input signal, a logical rule, and an output action. Yeah. Good. So let's move that to a little bit more schematic view. So this is the intelligent control app that is running on PXI-Core, and here you have these events. So as you see now in the next animations on the slide, this is the hardware where it is running on, and here we will see the web-based configuration where you can start programming those rules. Yeah. So if you now complete the animation, here you see the PRAESENSA system, which can either execute something, but it can also give input to the system, or here you have a Presidio system, which can either execute something or give input, but also we have the cameras, but also now new, the MQTT devices. Yeah, and in the blue block, this is actually where all the logic happens. Yeah, so now here a use case example, play a message based on a camera detection. Yeah, so the blue box is where the logic is happening. We get an event from the camera and we get an action to execute something based on the logic. Yeah, here is another sensor which could also bring an event, and there is another action which we would like to execute based on the logic. So if you complete the picture, this could be two cameras which are triggering this event, giving that to the intelligent control. Intelligent control is processing it, and then a specific action is being realized on the PRAESENSA system or the Presidio system. Like in this case, event number 1, line crossing event. It is being processed, and the action that is taken through the PRAESENSA system is that a recorded message is being played. Yeah, then we have the second event example, object in the field detected by the camera, also here processed by the intelligent control on the PXI-Core, and then a message is being played, in this case on the Presidio system. Okay, so if we move on, these are all the devices that we can now connect to the PXI-Core, and it all starts with a license on the left, which is the base license. This allows you to use intelligent control applications. Yeah, and then we have system licenses and we have kind of sensor licenses. System licenses would be a PRAESENSA system, a Presidio system, a G-series system. Yeah, and then we have sensor licenses, which is a camera or is an MQTT device. And if I look at the systems, every time when you connect a system, you need one license, and you can go up to 5 connected systems per system type. So let's say PRAESENSA as an example. Each PRAESENSA system I connect, I need one license, and I can connect up to 5. And the same goes for Presidio. So in total, 5 PRAESENSA systems, 5 Presidio systems. That's already 10 systems. Yeah, so it adds per system type. For the sensors, it's a bit different. If I look at the camera, which is the 4th column, you see 50 sensors maximum per PXI-Core, and every connected camera needs a license active. Same goes for the MQTT device. If you have a temperature sensor, for instance, this could be an MQTT device, 50 maximum, and you need a license for each connected device, or at least for each input stream to the PXI-Core or the intelligent control. Yeah. Okay. Next slide. Now we go into MQTT, a little bit more detail. So as I mentioned before, this is new. We already had the camera, the Presidio, and the PRAESENSA integration, as also the G series. But now this sensor type comes on top. And we believe this opens new project opportunities, because very often when we are in projects, especially that are a little bit more high end, let's take a tunnel application, or let's take a railway application, very often there are other sensors and other systems that we need to communicate with. And MQTT can give new possibilities here to make a seamless integrated system for the customer. So Anton, I would like to hand over to you so you can explain a little bit more on this topic for us.
Okay, yeah, thank you very much, Marta. Hope my sound is clear.
Yes, it's clear.
Okay, yeah, so MQTT in a nutshell, the intelligent control app will support this MQTT supported devices. What is MQTT actually? It's a message queuing telemetry transport protocol. and it's meant for a machine-to-machine communication and used in many Internet of Things IoT applications. The protocol is a set of rules that defines how the IoT devices can publish and subscribe to data over the network or over Internet. So it's always about subscriptions and publishing. We come back to that. So it's a message and data exchange between these IoT devices and industrial IoT devices, such as the embedded devices, sensors, PLCs, etc. So the protocol is event-driven and connects devices using the publish-subscribe pattern. So that publishing and subscribe. So if you publish it, and if you are subscribed already to it, and then when such event is published, then you will get the information. So the sender, which is then the publisher, and the receiver, which is subscribed to that event, communicate via topics and are so subscribed to a topic and will listen to that topic. But they are decoupled from each other. So it's something is in between. So we call that an MQTT broker. So it's an MQTT broker which keeps the information, and there you can then publish this information on a particular topic, and another client can again obtain the same information if it's subscribed to that topic. So one is publishing and the other one is subscribed to get the update. So this MQTT broker filters all the incoming messages and distributes them correctly to the subscribers. So much more information and background on MQTT you can find, for example, on this mqtt.org webpage in the Getting Started section. Direct support to many native MQTT devices are there when you look at MQTT in combination with intelligent control, which we had the app which is running on the PXI-Core. Via third-party gateways, it makes possible to have connectivity to devices with different protocols like Modbus, KNX, or SNMP. So there are standards of these type of protocol converters in the market which can provide that. So that would then be also a gateway connectivity to these kind of protocols. The intelligent control package comes with a dedicated MQTT broker. So if you install the MQTT functionality on the or the package contains already this, so it has an MQTT broker inside, which can then manage this publishing and subscriptions as mentioned above. So how does it look like a bit in this schematic here? You have the PXI-Core again, where you have multiple devices connected as shown before in the previous slide. You could have cameras, you can have intrusion panels, you can have PA systems like Presidio or PRAESENSA, and you have your intelligent control app doing the logic in between. What now comes next with this 2.1 version, or what is there now, is that you can also have MQTT connectivity to this PXI-Core and to this intelligent control app. Another option is then what I mentioned is that you could have a third-party gateway. So that's just a small box which can then again talk MQTT and convert that into other protocols. So the principle here is below an illustration of this MQTT support with intelligent control. On one side, it connects to the supported devices, so like PRAESENSA or a Bosch OnVIF camera, and on the other side, it behaves as an MQTT client. Via the dedicated MQTT broker, it communicates with the external MQTT devices. So, for example, here you have an MQTT device. It will, this is the PXI-Core with the intelligent control app and the broker running on that machine, on that mini machine, and you publish then a topic. And you can maybe that other device, another system could also publish a topic to that broker, and it can also subscribe to a topic so that it gets an update. So it can publish something on a topic which is here loaded, and it can subscribe to events which they want to receive updates from. Yeah. So, for example, here this MQTT device is then subscribed to topic 5, and this one is subscribed to topic 6. The next is then something internally. So this delivery of the broker to our intelligent control and logic actually is done automatically. So that means the communication, publish, subscribe, and deliver between the intelligent control application and the MQTT broker is all done automatically with no user configuration. So that's this part. So it will just then forward the topics to the event and action logic, which is in the rule engine, which is part of the intelligent control app. And then based on these events. So for example, if you have a particular topic where you want to do an action on, then that could then be an action based on topic 1 or on topic 2, for example. So yeah, you could say like maybe making a call. Yeah. Then you could feedback the event condition, or if you make a particular call and you or a zone activity could also be an event condition, which again then can be forwarded to deliver that topic 5 and topic 6 to the MQTT device. So that's how the feedback also goes back to and will be delivered back to your MQTT client here. Yeah, so this is the principal communication process of MQTT. Always having a topic, a subscription, and that way you can forward it inside the PXI-Core Intelligent Control app. So how does it look like then in the intelligent control itself? So there you need to define systems, you can define events, you can define actions. Here you can also see then which licenses are activated there, the overview which Marta gives, so you can upload these licenses here for the devices you need. Then you have the system definition. For example, a BMS system could be there. That could be a generic MQTT device, which is now possible in version 2.1 to add that as a system to your intelligent control app. And I have here, in this case, active in system controller. Yeah. So I will show it a little bit more detail now in the short demo, but first let me explain what I'm going to show you. What is on the left side is this generic MQTT device. This is an application now which is running on my machine, where you can post and receive particular topics. So you can there subscribe to a topic and you can post a topic. On the other side, I have a PRAESENSA system, which normally communicates only through open interface. Yeah, so that's this one is communicating through MQTT. So that could be your BMS server in this case, and that connects then to the MQTT broker app here, which runs on the PXI-Core. Yeah, so what happens? You can, for example, subscribe to a Z1 evac in zone 1, which is an evac priority. I want to have that update status here, and then you have some internal communication here. But at the moment that you create here an action, for example, for the I trigger a manual action. I could do that through this intelligent control app, but also by just making it now a manual call. And then the event condition will go back to the intelligent control app and report them to this topic that it is active, that the zone 1 evac is active at that moment. Yeah, so that's the basic principle here as a first step. Yeah. So then what you need to do is, you have your users to set. You need to have this MQTT broker installed. You need to add that new system to it, and then you can create your events definition settings here. I will show you later on more briefly how it then looks like. But Yeah, so when you have this broker here, so that this broker and you have this user, you can then on this user, it starts always with ext slash, in this case I have an MQTT topic called BMS. Yeah, so that's the topic where we are going to post on and where we are going to subscribe to. For example here, so that's then the new system definition, this root topic ext BMS. And now it will also be shown here when you create an event. Like here, I say this zone 1 evac event that I'm going to trigger, and then this will then trigger a call, and that will then also update then the MQTT event at the, and then that will mean here this action is there, is set1 evac active, which will then publish the message. In this case, the subtopic is then z1 evac, which is published back to the MQTT device. So this is now the information which the MQTT device will get from you at the moment that you really create a call. Yeah, and then again, then when the evac call stops, you can also trigger that again and back, that it goes back into false mode. And this can then be showed in the MQTT software. So this is basically the principle how it looks like. So let me let's go to the screen here. Second. Yeah, so here you can now see the screen, the configuration screen of the Intelligent Control app. I have a BMS system connected here with the topic there, and I have a system controller with a particular IP address. So these are the two systems which are connected. I have an MQTT broker. So this MQTT Explorer I created here, and then I have in the Intelligent Control app itself, I have created events. And when I create events here, like for example, if I have an evac call, and then this event will happen. So when I look here, like on zone 1, I create an evac, I give it that name, and based on the system controller 10, if it's busy or if it has a priority higher than 223 in this case, now when it's really an evac, then it should do something. So this is only giving the event, and based on this event, so that means when I make a high priority call on my system, then an action should start. So when I now go to MQTT evac active here, the action that's based on that event which I just showed, and now I'm going to publish the to that generic MQTT device, I'm going to publish the topic zone 1 / evac true. Yeah, and of course then also when it gets again inactive, it will be published as false. Yeah, so that's the action definition here. When it's inactive, and then you publish their false. So this is the logic which you can create here. Now, when I show you here the page of the of this topic, let's make it clear the history. So when I have here a call station besides me, and when I would make a call to the zone 1, you can see here now on the zone 1 evac, that's true. So when I stop this call, then you can see again that it's false. I did the same thing for a second zone. So when I will start second zone here, zone 2 evac true, and when I stop that call in zone 2, it will stop again. Yeah? Or when I activate both, of course that can also be possible. Yeah? So now you can see both topics are active unless I stop it again. Yeah? So with this, you have actually these topics available which show you now in which kind of status this zone is. So if it's in an emergency mode, but you could also think like if it's in a music mode or when it's active on a particular priority. So with that, you can really refer back in an MQTT client and what status this zone is. That's the example here, which I try to show you. Yeah. Yeah, another option, and that's the other way around. That's when you are going to publish something. I also created a publisher, and that means I have here on the BMS state, I publish off or on. And how does it look like in the configuration? So when you look in the event definition, and then here you have the on switch here. So that means here that the MQTT switch, so that means the generic device has a text equal to on, and you can have then on the topic again switch that to off as well. And then a particular action should happen, and that means when you have this MQTT on off switch defined, based on that you can also now create an action. So when I go to the actions again, then on the active initiated call, I call it. So, and then I can say play a message at the moment that the MQTT on switch event happens. So now I can really create a call based on this. And in this case, I had something like a message like an airport closing. Yeah. So this is the configuration what you need to do in the Intelligent Control app. So if you now have a device which is able to publish on that topic, on that BMS topic, an on status. Yeah. So yeah. So in this case, can now there's now a message started. Yeah. So and then again you can switch that off. This topic. So the message is played now. And this is also, you get also the feedback. I now have here all. I can show, if I show you the published ones, I published the on topic on BMS state, and I published the off topic, and I received on this device, yeah, also the off status back and on. So every time when you publish, you also will get it back. Yeah. So this is the way how you can create calls also from an MQTT device into an external system like in PRAESENSA.
Okay, thank you, Anton, for the presentation and demonstration. I would like to thank you all for joining. Let's stay in contact. If you have a project where you want to integrate with the PXI-Core Intelligent Control, let us know, and we will try to support you, and hope to see you, of course, in the next webinar. Thank you for joining, and have a good remainder of the day.